Well, the AI cat is out of the bag, and there's no putting it back. The people over at SemiAnalysis shared all the data they have on OpenAI's model, GPT-4. This includes model architecture, training infrastructure, inheritance infrastructure, parameter count, training data composition, token count, layer count, the multimodal vision adaptation, etc. Things that we've been wondering about and speculating on for quite a long time. Unfortunately, the thing costs about $1,000, so we don't get to see it until this guy reposts it for free. Now, he did get hit with a copyright thing. He had to take it down. But as you know, what happens on the internet, well, it stays on the internet. So let's dive into some of the most important findings. I'll try to put them towards the beginning. Use the chapters at the bottom if you want to skip around. And at the end, we're going to talk about what could this mean? What is this going to mean for Google and Microsoft and OpenAI? What is this going to mean for the open source community, etc.? If you remember that Google memo that got leaked, that might have been a little bit prophetic, as in like a prophecy to what was going to happen with OpenAI. Basically, they were saying that even though OpenAI is beating Google in some respects, both those companies, they were getting beat. They were lapped. They were completely annihilated by this third faction. That third faction was open source. So the question here is what's going to happen with the OpenAI, with their lead, with their advantage, if a lot of this stuff gets out there, if a lot of this stuff is shared with the open source community. As you'll see, there's still a moat that exists around GPT-4, but how long for, we don't yet know. So let's dive into it. First things first, here's the model size for up to 2022. So as you can see here, GPT-3 is at 175 billion parameters. Here's the language model sizes up to August 2022. Lambda, which is the Google model, 137 billion parameters. Palm Coder Minerva, which is the Google model, that's 540 billion. Again, there's GPT-3 at 175 billion. Here's a pretty good illustration of what that looks like. So as you can see here, OpenAI, ChatGPT, kind of Microsoft is a part of it. So you got the GPT 3.5, then you got Google and Bard, their Lambda and Palm models. You've got Chinese Ernie at 260 billion parameters, the Ernie bot. So a lot of people were wondering, where does GPT-4 fit into all of this? As some of these larger models are getting to be about 500 billion, is GPT-4 10 times more, 5 times more? Is it smaller? Is it the same size? The growth in model size is referred to as kind of a version of the Moore's Law, where it basically 10x's every year. Here they're showing a 15,000x increase in 5 years. So here they're saying that GPT-4 is 10x the size of GPT-3 or GPT 3.5. And it's somewhere about 1.8 trillion parameters across 120 layers. And layers are basically how the parameters are organized. So parameters are organized into layers. Each layer of the model represents different features of the input data. So if you're thinking about something like an image recognition program, some of the earlier layers, they might be dealing with recognizing edges and colors, whereas some of the later, the deeper layers, they're recognizing things like faces and objects, etc. So if this is saying that they have 120 layers, that means it's a deep architecture that can learn to do a lot of varied and complex tasks. Obviously, GPT-4 is probably one of the most advanced models out there. Next thing that's of note, and this is an interesting one, is they're using something called MOE, Mixture of Experts. Basically, instead of thinking of GPT-4 as just one static model, think of it as different experts. In this case, 16 different experts that each kind of do their own thing. So I haven't been yet able to figure out which one of them, which specific experts there are. But for example, there could be one that's dealing with coding. There could be one that's dealing with taking the information and sort of outputting in the proper form, like formatting or question and answer format, etc. So MOE is Mixture of Experts, MOE. MOE is not a new thing. It's been around. There's multiple studies with it. Google mentions it in one of the blog posts from early 2022, I think. So here's the AI Google blog, MOE with expert choice routing. So basically, depending on what type of question, what type of information you're asking for, it routes you to a different expert that then answers your question. So this is nothing new. Google knew about it, although I don't know if their models use it necessarily. So I'm not 100% sure. This paper seems to indicate that maybe the model that they built with MOE surpasses the performance of FLAN Palm, the 62 billion parameter model. So I don't think Google's models use MOE, but I'm not 100% sure about that. And so obviously the advantage that they're talking about is that MOE effectively and efficiently scales up language models without needing a rise in how much it costs and the resources required. So, and then this MLP thing they're talking about is an MLP is a multi-layer perceptron, which is this thing right here. No, wait, sorry, that's Optimus Prime. Never mind. Basically, in MLP, a multi-level perceptron is how these neural networks are. That's basically how the neural networks work. A perceptron is basically the basic unit of a neural network. So basically in this image, these are the different layers. Input layer, hidden layer, output layers, etc. So this would be a multi-layer perceptron. This is where I get a little bit out of my depth, so I'm not going to continue with this. You should Google it, or even better, ask ChatGPT. And then they also talk about how the routing is done. So basically, while a lot of people think that there should be this complex way of routing your different questions and tokens to which expert should be answering them, it sounds like OpenAI's is very, very simple. So this next part says there are roughly 55 billion shared parameters for attention. So you might be aware of the big paper Google released, I think it was late 2016 or 2017, called Attention is All You Need. That was one of the papers that did a lot of the breakthroughs in the space, allowing for these AI models to become much more complex. So the idea of transformers came out of that paper. Before that, these large language models, they had problems remembering kind of like where they started talking about. So as it started doing a paragraph, by the time it got to the end of the paragraph, it kind of forgot what it was talking about up here. Basically, they kind of had ADD. And so attention or transformers was kind of like AD&D medication. And then they started like remembering what they were talking about. And so that's what it's talking about here. So 55 billion shared parameters. So meaning that all the experts, all the models kind of use 55 billion parameters for attention. So again, attention, think of it as like the ADHD medication that you give these AIs so that they can remember what they're talking about. And attention in these models is also very similar to how humans pay attention, right? You walk into a room, you're not necessarily noticing every little nick on the wall or some dust on the floor. You're kind of like generalizing to see, okay, what's the important thing that I need to be paying attention to? So it's a similar thing here with these 55 billion parameters allow these models to focus on what's important. All right, so next we have inference. So inference is basically how these LLMs make prediction. That's what it's called, the ability to predict the sentences or predict which images you're going to use. That's inference. So I don't fully know exactly what that is, but this is basically talking about the efficiency of how much it takes to generate answers, to generate predictions, right? If a model is very expensive and very slow, these numbers would be higher. If it's fast and it's cheaper to produce, these numbers will be lower. So basically you want the best possible outputs at the lowest possible cost at the fastest possible speed. So again, I'm not sure exactly what numbers are good or bad, but it sounds like GPT-4 is doing a great job. So I assume these numbers are really good. So next we're talking about the data sets. How we train these AI models is we just kind of let them loose on large, gargantuan amounts of data. And with LLMs, tokens are sort of like the basic units that text is broken into. So for example, you can think of it as, for example, like words or letters. So saying that it's trained on 13 trillion tokens means that it processed 13 trillion pieces of text. And so in machine learning, you have these epochs. So you can think of what an epoch is when the entire data set has been fed through the machine. So if it's multiple epochs, then there's some multiple passes through the data. And so here they're saying that there's 2 epochs for text-based data and 4 for code-based data. And there's millions of rows of instruction fine-tuning data from Scale AI and internally. So fine-tuning is basically taking a large language model, sort of like the base model, and tweaking it to perform certain tasks a little bit better. So for example, if you have a model that is able to recognize images, you can take that and let's say you just wanted it to be really good at recognizing dogs or human faces, for example. And so you would go in there and you would fine tune it to be great at that one particular task. So Scale AI is a company that provides a lot of these high quality training data for AI. And then internally is OpenAI's internal data sets, whatever they're using. So next they're talking about the sort of the context length. And this is, I guess, referred internally as seqlen, sequence length, seqlen. And then, so the context length was 8K. And then after training, the 32K seqlen version of GPT-4 is based on fine-tuning the 8K version after the pre-training. So next we're talking about the batch size and how it was gradually ramped up over a number of days. So the batch size was gradually ramped up over a number of days on the cluster. By the end, OpenAI was using a batch size of 60 million. This, of course, is only a batch size of 7.5 million tokens per expert due to not every expert seeing all the tokens. So again, depending on which expert you were routed to answer your question, that would decrease that batch size. Again, that's a little bit outside of my knowledge zone, knowledge base. So if you have some more insights about that, please comment. I read every single one. Thank you. And then so this next one is very interesting because here's they're talking about what hardware they're using and how much it costs. And so let's come back to this thing in just a second. But let's look at this training cost. So they were using something like 25,000 A100s, which is that NVIDIA GPU. So it was probably something like this and cost about 25 grand, and they had 25,000 of them, or more likely it was since they were probably training in the cloud. So as far as I know, OpenAI has never disclosed how they train their models, what software they use, if they use the cloud or they use physical GPUs or whatever. Since they have that deal with Microsoft, they probably use Azure, Microsoft Cloud Service. I think they actually get some, not free, but they get some sort of a sweetheart deal where they get to use Azure's network. So they're probably using that to train it. And so if their cost in the cloud was about $1 per 1 hour of running these A100s, so the training cost to train GPT-4 would be 63 million. And so today's equivalent would be the H100 Tensor Core GPU from NVIDIA, which NVIDIA, if you need me to review any of these things, please just send them. I'll find some time to do it. Just send them over and I'll review them. No charge. And so they were training this for 90 to 100 days, which if you think about it, so, these big corporations with a lot of money, they still have a pretty big advantage to creating these large language models. I mean, yeah, now with the H100s, that might only cost, 21 million, 22 million to train in 100 days. Or excuse me, for the H100, it would be 55 days. For the quote unquote older A100s, it would be 90 days to 100 days. But still, obviously, this is out of reach for most people, most companies. But the interesting thing is how fast the price is dropping and how rapidly the size of these models is increasing. So I'd be curious to know at what point can a small business, let's say they have a 6-figure budget, how many years from now could they recreate GPT-4? At what point will it be sort of financially feasible to do something like that? Might not be that far away. And then 32 to 36 MFU. So MFU is machine fabric utilization. So it's basically how much of that time was, how efficiently were they utilizing the computational resources. And 32 to 36%. So that means that a significant portion of that computational capacity was not used. And so they're saying there was an absurd number of failures. So where you had to restart from a checkpoint, which is part of training a machine learning model. So you can think of it as you're going through a video game, you hit a certain checkpoint, and, the game saves and you restart. But if you fail doing that part, well, you go back to the checkpoint. So what they're saying here is looks like GPT-4, there were parts of it where they kept having to reset back to the checkpoint many, 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 many times. And that's what was causing such a low efficiency of using these machines of the A100 GPUs. So a couple other things, like when we're talking about MOE, mixture of experts, one of the, in the research articles, research seems to suggest that sort of the optimal amount of different slices or experts of the model to use is 64 to 128 experts, that achieves better loss than 16 experts, as is the case with GPT-4. But of course, the more you use, it could be harder to achieve convergence. And so one of the reasons why OpenAI probably chose to go with a smaller number of experts than what research suggests is optimal is probably because it was such a massive run, this training run. It was so big, it cost, we assume $60 million plus, and that's just how much it costs to run the GPUs, just how much to run the hardware for that. So maybe they chose to be a little bit more conservative just to make sure that they could produce good results with that. And so before, OpenAI had their DaVinci model, and so GPT-4 costs 3 times more in general, per guess, per prompt. It costs 3 times more. That's why you're going to see in a lot of these studies, like for example, the NVIDIA Minecraft study where they had ChatGPT basically write code for Minecraft that it would execute to make it play better Minecraft, explore more and learn how to do all this stuff. It's interesting because they used GPT-4 in some areas, and then they used GPT 3.5 Turbo in others. So for example, to write the code, they would use GPT-4. To write the code comments and a little descriptions of what the code does and to make titles for what the code is, they would use the cheaper, faster model, GPT 3.5 Turbo. And so one of the things you might remember when GPT-4 came out, they were saying that it was going to be multimodal. It was going to have vision. It was going to be able to see stuff. And that was exciting, but we haven't really heard anything new about it since then, since GPT-4 was released. Although we saw in the demos, we saw that it was real. As far as, if I remember correctly, they did show certain applications where it seemed like it was working. Although, we didn't actually test it, so we don't know if it's real or not, but we saw what looked like vision with GPT-4. And so it looks like OpenAI wanted to train its vision from scratch, but that was a little bit risky. GPT-4 was still sort of early, not mature enough. And so the primary point of vision, and this is where to me personally gets kind of exciting, but I think the goal for a lot of people, myself included, is to at some point be able to create these autonomous agents. Have these AIs go and read the web and transcribe what's in images or videos or websites, etc. Now, right now, you can use some of that with like Python code, for example, but vision seems to be what would completely just take it to the next level, just completely blow it out of the water, because instead of sitting there and using something like OCR, the image recognition software for Python or whatever, you would just have ChatGPT, GPT-4, be able to look at the web page or an image or a video and just sort of gain insight from it, figure out what it's saying. I mean, for those of you that have had a chance to work with ChatGPT's code interpreter, which is now should be available to everybody with a pro license. If you don't have it, check your settings in ChatGPT and then scroll to the top, and it should be one of the options under GPT-4, code interpreter. So as we've seen there, it's getting pretty smart about being able to look at data and create images and even recognize images. So we're not that far away from it with what we have existing, but really GPT-4 vision, as it was sort of promised, we're not quite there yet. And so it seems like what they do have right now, it's still behind closed walls. We don't have access to it, but they have vision that's able to read text. And they're able to read little scripts like LaTeX, to where if there's sort of a printed graph, they're able to kind of figure out what that graph looks like, what it says. And OpenAI also has Whisper. So that's its ability. It's able to listen to audio and then transcribe it. So for example, if you have a video playing or a podcast playing, Whisper would allow you to transcribe it and feed that into ChatGPT. And then it would be able to understand what this podcast is saying. Another thing that they talked about is speculative decoding. And this is something that I've seen in other studies as well. Haven't had too much of a chance to look into it, so I apologize if my understanding of it is a little bit fuzzy. But as far as I can tell, since GPT-4, it's smarter but slower and more expensive. And for example, GPT 3.5 Turbo is faster, cheaper, etc. But it's not always right, or it doesn't handle some of the more complex tasks as well. So for example, for coding, sometimes it's definitely not as good as GPT-4. And so one thing that people have been testing is they'll ask a question to both of them at the same time. And once the smarter model starts answering, once it sees those first few tokens rolling out, then it'll give that to the faster, cheaper model, and that will take over. And that seems to produce pretty good results for cheaper, for less resources. So you think of it as like, you ask a question from a smart person, you're like, is it probable that it'll rain today? And the person starts, yes, it is probable. And the faster model jumps in and completes the sentence for him. Yes, it's probable it'll rain today, right? So the smarter model sort of sets the direction of where that answer is going, and the faster, cheaper model picks it up and continues with it. At least that's what I understand it as. And you might have heard about the conspiracy theory about, GPT-4 or whatever being not as smart. People have been saying like it got a lobotomy, like it's just not as smart. It's not able to do certain tasks well. And, OpenAI's official response is like, well, GPT is it's the same thing. Nothing's been changed. Well, both of those might be true in this sense, because GPT-4 might still be GPT-4, but the responses we get from, ChatGPT, that sort of customer-facing thing, it might be using this speculative decoding. So basically, GPT-4 starts to answer, and then the faster model picks it up and then screws it up. So that's a speculation of why that might be happening. And so they're using that to save costs, basically. And so one of the questions that's been asked about OpenAI, where they get their data training from. There seems to be this idea that they have some secret underground data that nobody else has. Now, you've probably seen that GPT-4 passes a lot of the exams like bar and a lot of other advanced exams for college level courses. Pass a lot of the multiple choice questions in professional and academic sort of settings and exams. And so the rumors and the speculations is that a lot of that sort of secret data is just textbooks, lots and lots of textbooks. And so that would explain why GPT-4 seems so smart to anybody that uses it, right? So if you're like a college professor and let's say you're a computer scientist, you ask it questions about computer science and it tells you the textbook answers, right? And so that's because it's been trained on those. Or if it's talking about biology or philosophy or whatever. And so there's some rumors and there's certain things that kind of maybe point towards it. I'm not 100% sure, but that could certainly mean trouble because that could be legal trouble for OpenAI. That could mean people start asking questions about, hey, where did they get this data from? And of course, Europe has very strong laws against using stuff like that. I think in the US, it's kind of nebulous still. We don't really have too many laws about how data is used to train AI models. I think we're just beginning to talk about it. Japan is on the other side of the spectrum. They're just like, there's no copyright whatsoever that applies to training AI models, right? So if you're training an AI model, you can use anything without regard for copyright laws, right? So any artwork, any movie, any whatever, just use it if you're for the purpose of training AI, which personally to me makes a lot of sense. And I know that's a controversial opinion. I know a lot of artists are very much against training AI on the artist's works in order for that AI to then spit out art. I get that that's, problematic for a lot of people. It's going to put a lot of people out of business. But there is an argument to be made that's how humans learn as well. Writers read a lot, right? Other artists study artists like themselves to learn. So this is the same way we train ourselves to become better. It's doing the same thing. But obviously, it can produce a lot more than one person, right? It can produce more art than the entire human population. So there's that. So I hope that you found that interesting. If I missed anything, and that's very possible that I got something wrong or missed something, do comment down below. You can be nice about it. You can be rude about it. I don't care. But explain what you're talking about. Give us some context so that we can verify what you're saying and maybe learn a little bit from it. What does this mean for Google, for Microsoft, for OpenAI? What does this mean for the open source community? Does this mean that there's going to be an open source GPT-4 in sometime later this year? I'd love to know what you think. Comment down below. If you're interested in learning more how to use this technology, even if you have no coding background whatsoever, that's the very thing that I'm working on next. Check out the show notes. I link to natural20.com. That's my website. Sign up for the newsletter. And as soon as that course gets rolled out, you'll be the first to know about it. My goal is to create an autonomous AI agent that is able to make money and run a business. And it is beginning to seem like we're getting closer and closer to that being able to happen. If that's something that's interesting to you, stick around. My name is Wes Roth, and thank you for watching.